And so a little bit about myself. I'm relatively new. I joined NC State last year from Department of Energy's Brookhaven National Lab. My area is on radiation detection, both on, as you can see from the title, detect materials and detection devices. And so what do we do in the group? And I think some of you may be very familiar with this kind of situation at the airport. And yes, you do need good radiation detector, to check your luggage, this kind of thing. And also at the dentist, you need some good X-ray detector to check the cavities in your mouth. And of course, we are nuclear engineering, and there's a lot of applications for radiation detectors in nuclear plants. As you can see, there's some radiation survey map. As you can see here, before you really go to the pole, like you want to understand where the radiation level is high, where the radiation level is low. Similarly, about those pipes, you do want to understand that before you start to operate or do some maintenance. And there's a lot of applications in medical imaging with the radiation detector. And some example like the PET and the SPEC, those terms probably you are very familiar if you go to the hospital, like it's pretty normal these days. And you can see the different, some organs, they are normal, and some organs, if they're not normal, if there's some tumor, this kind of thing, the distribution of radioactive isotopes, they're not uniformly distributed. With a good radiation detector, you can easily distinguish that. All right. Of course, for environmental study, like this, some picture of Fukushima accident, and you want to do some environmental survey to get an idea how those radiation distribute. And of course, in one word, this kind of research, it's mainly driven by the application, because there are so many applications related to radiation detectors in our society. It's so useful. And I want you to get an idea how you can make a good detectors. And it all starts from the detector material growth, this is some example about some compound semiconductors. Of course, we can also work on some scintillator material and so on, also some neutron detectors. And from the detector material, then we cut and polish. We deplete the electrode there, then fabricate that into modules. And then we assemble those modules into some devices. Like you can see this, we put a different module into, assemble them in, and then put them into a system. All right, so what do we do in the group currently? There's a few exciting research opportunities here. And number one, of course, we want to explore next generation and some new material for radiation detection, which will bring us a lot of opportunities. And also, we are interested in some study on the advanced radiation shielding materials through additive manufacturing. And we also want to do some study to understand the radiation electronic material and some stuff. And some example, this is some compound semiconductor material. And our goal is to get a better performance with a lower cost, because if you want to really put your study into the application, you do want to have a reasonable and lower cost. Okay, that's one of our goal, and we want to get a good performance with lower cost. And some example about some type of perverse type gamma detector. This kind of thing, it's we use solution growth instead for this way, because currently, the melt growth, it's the most popular way to get good quality materials, but at the same time, the cost it's higher than the solution growth. We are working to see if we can get even better material or at least at the same quality with the solution growth at a much lower cost. Just want to show some latest picture. We took this picture last. One of my students, like Zheng, he works with me on the growth of the detect material. We got some single crystal last week. We are working to characterize that right now. Okay, and basically this is the overloop of the whole study. It all starts from material development, and then we fabricate those materials into the detector, and then we do some detector test, use the feedback from the detect test to improve the material growth and annealing process. All right, another topic is I mentioned before. It's about the radiation shielding materials through additive manufacturing. We try to use some special 3D printing machine to fabricate some with some special filament and to fabricate some radiation shielding material. This project is currently supported by our university's faculty research and professional development program. And another thing is we try to understand the effect of electro and optical, electronic, this kind of material. We want to understand the effect of radiation on their performance. And all right, some takeaway message. So advanced radiation detector has so many applications in our society. Okay, and we want to develop better detector material to promote their applications. All right, and if you have any question, you are very welcome to contact me. And anytime, just shoot me an email, give me a call anytime, okay? And I thank you for your attention.